Welcome back to Industry X Extreme, where we navigate the currents of innovation shaping the future of industry. In today's episode, we are venturing into the data driven heart of modern manufacturing with our special guest, Samar Khan. With a distinguished career that spans Google, Microsoft, and now a leading role in manufacturing powerhouse, Samar brings a wealth of knowledge on how data engineering is revolutionizing the way we produce, innovate, excel in the manufacturing realm.
Hi Musarrat, how are you?
Yeah, I'm doing good. How are you?
Yeah, I'm also fine, and I want to thank you for inviting me to this podcast. Yeah, and I think it's a great way to share the knowledge, and yeah, I'm grateful for getting invited here.
Yeah, pleasure is all mine. You are helping me out. We are trying to educate the world about Industry 4.0, and today we are going to have a conversation with you about data engineering and how it shapes the manufacturing industry. So, can you share with us your journey into data engineering and what drew you to specialize in this field?
Okay, yeah. So basically, before going into data engineering, I would just like to provide a little introduction. So myself, Samar Khan. I hold over 8 years of experience in IT industry, and I started my career in 2016 as a software engineer working for Bank of America. And if I talk about data engineering and how I got into, so initially I was working as a software engineer, where I mostly as I was working in bank, my task was mostly to build softwares and build UIs for the finance industry. And that time data engineering was not known, or I would say it would exist, but this term data engineer didn't exist that time. That time we used to have like database analyst, or you can say like database specialist. But eventually, as the market changes and lot of artificial intelligence, machine learning, all those things came into picture. And one more thing was that the amount of data that started getting generated, earlier companies used to have very limited amount of data, but with this change in the industry, a huge amount of data started getting generated, and we needed more experts who can handle data and process data at a faster, or I would say in a more meaningful way. So then this term data engineer started, and when I joined Microsoft in 2019, I started working on this field, data engineering. That time I didn't know that okay, this work is related to data engineering. I knew that okay, I have to work on database, I have to write a store procedure, I have to do some things like get the data and do the processing. But yeah, eventually I got to know that yeah, it's all work is related to data engineering. And if I say like what is data engineering, basically it's all about processing, analyzing, and generating meaningful results from the data. Yeah, so that's all has been
Yeah, that
from,
sounds
yeah.
interesting.
Yeah.
So, data engineering. So, so what I have understood so far is that we have to process the data in such a way so that it can provide meaningful results.
Yes, that's correct. So yeah, what happens is like when this trend started of artificial intelligence and machine learning, the companies always had the data, but they never had a platform where they can basically generate business insights from that data. All they were
Okay.
doing was showing the data or using it for their own purpose. But to build that platform, basically those AI or ML engineers, they needed that platform. So to build that platform where they can have data from maybe different systems or from different domains, they needed data engineers. And that's how like this trend of data engineers started. Yeah.
So, having worked with tech giants like Google and Microsoft, what unique perspectives did you bring from those experience to the manufacturing sector? Since you are working in a manufacturing company right now, so
Yeah.
what do you think that how that data engineering fits into a manufacturing company?
Yeah, so if I talk about manufacturing, right? Earlier, how manufacturing used to happen was like it was all kind of little manual. Not, I would say not manual, but I would say it was, they were not using the data in a right way. They were maybe getting like in manufacturing, like if they are if they have a manufacturing system and they know that okay, if one of their system or one of their loop is not performing in right way, they had little checks where a person used to go and manually fix those things, or the amount of products that they were generating, right, the sales that they were having, they knew that okay, they had a fixed set of clients, and those were the clients that they used to like deliver the products. But they didn't know that okay, like if they want to know okay, what will be my sales in January, or which month of the year we expect more sales, or which month of the year we have a cooling period. Also, like if they have an issue in their system, can they like, do they have to do it manually, or if there is an automated way of detecting that issue before itself, or if not detecting, maybe mitigating it in a automated way. So that's where data comes into picture. They can, they, if they are like, if they have a data of last 10 years, 20 years, or how long they have been running, they can use that data to analyze the trends or the charts and analyze the sales. All those things they can now do with their data, right? Like rather than a person going and pulling the lever or pushing the button, they can have the AI or they can have the machine learning to do it for them. So that helps a lot in terms of manufacturing. That helps them in increasing their efficiency, in making them more robust. Yeah.
Okay. Okay. So, what I have seen is that earlier they were not companies were not using data engineering that much because they were not were aware of the power of data. So, in your
Yeah.
view, how has the data engineering transformed the industry in recent years? So, what changed? What caused this change?
Yeah, so basically, yeah, as I said before, like it to depend on the amount of data. That's the first thing, like the amount of data that's get generated. And the second thing is the availability of tools. Basically, earlier they didn't have so many tools to process the data. Like I would say, like they didn't. Now there are new cloud providers, Azure, or if I talk about like uh, Google Cloud or Amazon, they are providing some readily available services in which you can just plug your data and they can give you business insights. So earlier there was no such tools to do this. Anyone has to do things manually or write an if and else statements, or maybe I would say do it in a more old fashioned, or I would say like a manual way. But now with this availability of tools, with things getting easier, like they, and with the faster processing of data earlier, because the rams, or I would say the processors, were not that fast to process such. But now like even in a small place you can fit a large amount of data, as well as you can process it. And now clouds are there, you don't have to maintain. Earlier what company used to do, they used to delete the history, or maybe like kind of what I say is like they used to uh, uh, archive those data.
Archive
But
them.
now they
Yeah.
have, yeah, archive those data. But now they don't need to do that. They can just put it on a cloud, or they can just buy a system and put it there, and they can process it. Just it's kind of right now like a plug and play systems. And now algorithms are there, you can just provide the data and they can give you the insights. So that has caused this change over the last 10 years. Yeah.
Yeah, that's a really good insight, actually. The availability of tools was the issue that they were not able to process data, and now machines have upgraded in such a way that we can transform data into meaningful insights. So,
Yeah.
can you provide an
Yeah.
example where you have used data engineering and improved some manufacturing process or outcomes?
Yeah, so currently, if I talk about my recent experience, like right now I'm working for Voith, which is basically a paper and pulp manufacturing company. What they do is like they build machines which are installed in paper mills and helps them like basically measure the pulp, basically the viscosity, the density of the pulps, and the control loops that they have, in which they maintain a particular temperature. They want to know the brightness of the paper that they are producing, means if it's light white or if it's really white. So earlier what they used to do is like they used to take the sample of the paper, and they used to basically send it through a lab or something to check the brightness level on. But now what they have done is like they are using image processing, like they have installed the cameras which captures the image, and automatically through an algorithm they get to know that okay, what is the brightness of that paper, and if are not getting the correct brightness, the software will automatically adjust the viscosity of the pulp, or they will add more chemical into it until it gets the right amount of brightness. So that's where you can see a long process which might used to take 1 or 2 days has just gone into maybe it's a matter of few seconds. So that's, I think, yeah, one of
Yeah,
the
yeah,
example that
that's
I could
really
think of.
interesting.
Yeah, yeah,
Yeah, that is
yeah,
really interesting to look into how computer vision is transforming the quality process. That is
yeah,
really good insight.
yeah, yeah, yeah.
So, coming to challenges, like what are the biggest challenges you have faced while implementing data engineering solution in manufacturing?
Yeah. So basically, with data engineering, it works apart from other software engineering, it works in a little different way. So in data engineering, in software engineering, okay, they want you to build a website, or they want you to build maybe a shopping website or anything like that. Okay, like okay, I need to use this in the back end, I need to use this. But with data engineering, little with data engineering, first you need to know what you really want. Basically, you need to know the problem that you want to solve, and then only you can start implementing based on that. So it's not a very, what I say is like, it's not something very trivial that okay, for data engineering I need to do this and this. Basically, if you are building your database, you, before building the database itself, you should know what knowledge you want out of that data. So suppose if you want to know, okay, so if I take an example of Uber or anything, you want to know, okay, how many drivers are there in this particular location, or what is the average time that a driver took to reach the pickup place or reach the destination. So first you should, first before dealing into data engineering problem, first the person should be asking the right questions, that okay, what knowledge does he want, and once he have those questions, then he should dive into basically building the database. That is one key factor here. It's not like that okay, I have built a table and later I will say okay, like I want this, because then it will be doing the reverse engineering, that becomes little difficult. That is one thing. And the second challenge that in terms of data faces is the, what I say is like, is the delay, or I would say the timing, like how fast you want the data. Do you want the data to, okay, if you get the data today, you process tomorrow, or do you want the data to be in real time? So those kind of things matter a lot in the beginning of any project. So yeah, those things I think are like, if I talk about like, these are the challenges that one
Uh-huh.
should be like facing, yeah, before
Okay.
starting like any work in data engineering. Yeah, yeah.
Yeah, when it comes to data, there is one word which is in fashion right now. It's called big data. So, how big data comes into picture in industry, manufacturing industry, or any other industry?
Okay, yeah. So if I talk about like big data, basically in a survey which was published like quite some time back, I don't remember, but the amount, it says that the amount of data generated till, maybe I will give an example. I don't remember the exact year. Maybe you can say that amount of data that generated got till 2015 is exactly the same as the data generated from 2015 to 2020. Or I would say like the amount of data generated in the last 5 years is equal to the amount of data generated entirely since then. So as you can see, right, like technology is weaving into the our lifestyle, and everything that we touch or we feel or we see generates an amount of data. So big data is all about that enormous amount of data that is present, maybe in terabytes is a small thing, petabytes. And big data comes into picture because when we started building tools, or when companies started building tools for the data, they understood that okay, like we cannot do it in an old traditional way, because the amount of data is so huge. We need to think of different ways to handle the data. Maybe it's a parallel processing, or it's an asynchronous processing, or those kind of things, maybe using multi nodes or a cluster
Mhm.
of servers to process those data parallelly. So when those kind of things came, they invented this term called as big data. Basically these softwares, or Spark, Apache Spark, Hadoop, they are built mostly to handle such amount of data and do that processing in a faster manner.
So,
Yeah,
with big data comes AI. So, you have
yeah,
told one AI example in your a company that where you are using computer vision to analyze the quality. So, do you see
yeah.
any other applications that can be done in terms of manufacturing where we can put AI or machine learning?
Yeah, I think there are a lot of places there we can use. One thing that I think manufacturing, in terms of manufacturing, would be like to basically each manufacturing companies goes through like a shutdown period or some maintenance period. So I think there, they, rather than like stopping business for that particular time, maybe they can analyze those things which they do over the period of time and see like if they can be done like in an automated way, or AI can take a decision for that. Like I might not be very right, but I'm just guessing. Yeah. And one more thing that I could think of, yeah, would be, yeah, like predictive maintenance, as can be a word to say that. Yeah, like one can know that, okay, based on the data that those machines are generating, what time their maintenance can be done, like they can do that maintenance in slots or in some other way. And another thing would be to use the sales figure, right? Like based, suppose they know that, okay, in January they have the major sales for the product that they are building. So they can basically, by analyzing this data on month basis or on week basis, they can basically increase or reduce their workforce. That I think would help them a lot. Maybe they can see the data for last 20 years. Okay, in last 20, every time this month they have less amount of sales, so they can maybe give a cool off period or a time off period for the workforce or things like that. Yeah, yeah, yeah. So that's one thing, yeah, to think of. Yeah,
That's really
yeah,
interesting to know. I think many people will find out that there are many applications of AI and big data
yeah.
in various industry. But we are a manufacturing based podcast, so we are focusing
Yes.
from on picking your brain on this
Mm,
only.
yeah,
So
yeah. Manufacturing. Yeah, yeah,
so let's talk about like collaboration between IT and manufacturing teams. See, there are manufacturing guys who work on shop floors and they don't know much about data. They just want
yeah,
just want to see some meaningful insight. So, how
yeah.
important is it for data engineers to have an understanding of manufacturing processes and vice versa? Like, if how important is for shop floor guys to understand about data?
Yeah, yeah, yeah. So I think it's all about like, I think for the, yeah, shop floor guys, I think what they only look for, first thing is that if they are in the manufacturing industry for quite some time, maybe 10 years, 20 years they're working. So the problem is that they don't like a lot of change in there. Like if they are pulling a lever or they are pushing a button every 30 minutes or every 1 hour, they don't want to change that. That is one thing. So to basically build their trust on like newer technologies or an easier way, first we need to make sure that we are providing something very simple to them. If we are even providing, rather than a button, if we are providing a UI, we should make sure that it has to be very user friendly and for them to easier to understand. That is one thing. And they might not go into data, but yeah, they can help the data engineers to understand or build such system which they can use it easily. And for data engineers, I would say, like, it's really really important to understand the problem, as I said before, right? For data engineers to work, first they need to know, okay, what knowledge I need to extract out of data, or what questions are there, or what are the problem statement. To understand that, I think any company like Cipla or any manufacturing companies, they basically send their engineers to their plant and show them each and everything and explain them in detail. So that helps them to build a better system for the people who are on the ground. Yeah, yeah,
Yeah, I understand. Like having process understanding will give you a insight into the brain of the manufacturing people, and they will like you more.
yeah, yeah, yeah.
So
That's correct. That's
actually,
correct. Yeah, yeah, Yeah,
Yeah, actually, what I do is even in my projects, what I do is I first make them understand what facilities or what solutions does a tool provides, and then we
yeah,
show them a few demos, and then they will be having better understanding, and the requirements will be more clear and final. Otherwise, it will
yeah.
be an agile project, changes coming at any times that.
Yeah, yeah,
Um,
yeah, yeah. That's what basically manufacturing is not like IT or software industry where you can just push a change every month, right? So you need to be very, very robust and kind of like very, very, I think it should go through a lot of testing and checks before like you push a release. So yeah, that's that's the difference actually between normal software or service provider, service industry or manufacturing. Yeah. Yeah. Yeah.
So, coming to the emerging trends, like there are a lot of technologies coming, bubbles are there, there are some long-term players also. So, we hear about IoT, blockchain, edge computing, and all those things. So, what do you think? Which emerging trend in data engineering do you believe will have the most significant impact on the manufacturing sector in the next few years?
Okay. Yeah, I think okay, if it's talk like I'm little like very new to manufacturing, so yeah, like I'm like let me think about it. Like it's not on top of my head, but yeah, with I think blockchain or I would say like edge computing is still a far-fetched goal for manufacturing because they are right now still like very I would say traditional and they are still like very hesitant to like
Yeah.
in adopt new technologies. But one thing I think they should be really doing is that like putting a lot of effort into like utilizing their data or I would say like do real time data analysis of their machines and system. That is I think is really really important for them to basically understand. Also one more thing would be to like involve a lot of sensors or I would say like involves a lot of IoT devices. That is I think very
Mhm.
important for manufacturing. Yeah, to incorporate, maybe not use them right now, just incorporate them in their machines so that they can get the data and later they can use think of a problem or they can think of using it the right way. So I think IoT devices is something like they talked about image processing or I would say video processing or I would say like basically showing the data as a chart or a trend or in those way. I think that would help them a lot. And they
Yeah.
are yeah they are quite afraid also to do any new change, which I think they should not be. Like they should try to maybe adopt, because if I talk about things like if you say Nokia, right? Nokia was such a great company, but they were not very um, keen into using the Android or adopting their phone, and now they are nowhere. So I think only those manufacturing companies will last, which will basically adopt these IoT and data engineering or machine learning technologies, because that's gonna help them improve their efficiency in a way they couldn't think of it right now.
Yeah, actually, in right at present, I get a lot of calls for IoT integration and AI and uh, ML applications of the data. But the things when I visit the plant is that the data is not there. They are not capturing data
Yeah,
right now. And if you want to
yeah,
train AI models, you will be needing
yeah,
lots and lots of data.
yeah,
So,
yeah, yeah.
so any
That's the
advice
thing.
for aspiring data engineers who are looking to enter the field of data engineering? What skills and knowledge area would you recommend focusing on?
Yeah, I think if anyone wants to get into data engineering, the first thing he should be very good at, like, is I would say like SQL, because I know like it's a little old, but it's used widely, and people say they are good at SQL, but actually they are not. Like SQL is very vast. That is one thing, and the second thing would be to understand how to, like, lot of people focus on languages, like they want to learn Python, they want to learn Star, but that's not the real concept. I think database modeling is one of the main important concept in data engineering, which everyone should focus on. Like right now people are not get into theory, they know 10 tools, they know Azure, they know GCP, they know lot of things, they know horizontal vertical scaling, all those big words. But if they ask them, okay, can you build me a database model for my shopping application or for my Uber systems or for my manufacturing, they might not be able to do that. So I think they need to get into the theory, the old theory, the schemas, the snowflake, and the star, and all those things. They need to get into that before like getting into data engineering, I would say. So yeah, dive later into theory, and then go for talking about like multi-processing or clusters and all those things. Yeah, yeah, yeah.
Okay, okay. Yeah, that's a really good advice. First, clear your core concepts and then dive into tools.
Yeah, then dive into tools. Yeah, yeah, that's correct.
Are there any resources or pieces of advice you wish you had when you started your career in data engineering?
Yeah, yeah, yeah. I think, yeah, like when I started, actually, I didn't know about data engineering, and then, yeah, that's the one thing. Like I thought, I think like I should have studied little bit before like working, because sometimes you know what happens, like when you start working, then work becomes so much that you just do the work, and you don't delve into like theory or getting to know what you are doing. I think
Hmm.
that's one of the major problems that everyone faces, because they are doing their work 9 hours a day, and then they don't want to know that why or how they are doing this work. So that is one problem that I think like almost 90% of the guys do. So I would recommend that before starting any work, or even if you have started also, maybe read little bit about it, 10 minutes or 15 minutes, to get a better, that will help anyone to build a better system, and it will save them also a lot of time. So yeah, I think that is one thing, that is the one advice that I could think of. Yeah, I also think sometimes like I should have studied, like I have worked on Spark for almost a year, but yeah, I did the work, I understood it from the top, but yeah, like sometimes I think I should have dig deeper, studied more, so that I could have, like right now I think, okay, I faced that problem that time and I solved it that way. Right now, if I had that problem, I would have solved in a different way, because now I know things more. So that is one thing that I think like everyone should be doing. Yeah. Yeah.
Yeah, actually, that's what when we look back and think about the challenges we faced in the beginning of our careers and how we dealt with it, and we feel quite stupid and see that we could have done it better if we would have studied better.
Yeah.
So,
Yeah.
uh,
Yeah.
basic concepts are very important to uh,
Yes.
master on first. Yeah.
Yes, yes, yes.
So,
And yeah, whatever we work
mm,
on, we should always know, like, okay, like this is the problem and this is what we are doing basically. Like what we are trying to solve here. That is one thing that's really important that one should know. Yeah.
so that brings to the end of our podcast episode. And Samar, you have been really providing very good insight into the manufacturing and data engineering role available and the challenges we face in this industry. And I hope that you will be coming again soon and shower us with more of your knowledge.
No, no, that's I'm really grateful, and yeah, thanks for this opportunity, Musarrat. Yeah, it's been quite some time since I gave it any podcast, and yeah, thanks for inviting me, and yeah, thanks a lot for your time also.
So this was Samar Khan and Musarad Hussain talking about data engineering and manufacturing. And until next episode of Innovate X Stream, have a nice day and a week. Thank you all.